All right. I believe we are live. Aloha everybody from the OWASP Hawaii chapter, out in the middle of the Pacific Ocean, far, far away from any other land masses that you might be tuning in from. My name is Jason Sewell. I'm one of the chapter leads for OWASP Hawaii, and really want to, thank everybody for tuning in today. I hope you've had the chance to check in on some other chapters around the globe and see some good talks and hopefully connect with some interesting people in the process. We are the Hawaii chapter. We have two talks coming up today. Actually, before I get into the talks, I do want to kind of just give a moment of recognition for kind of what's going on in the world around us. And there's a lot going on this week, and I hope that the purpose of a global event like this can bring us together within the AppSec and the broader InfoSec community to help kind of lift each other up and support one another as we go forward. If you are tuning in from Hawaii, please do follow us on meetup.com, and we'd be happy to welcome you to the community. Having said that, I do want to just get right into the talks. And first up, we have Alex Shantavi, a local boy from Makakilo here on Oahu that has gone on to do some really exciting things. So he's going to get into his talk about cartography, which is a tool that they built at Lyft to use graphs to improve and scale security decision making. So with that said, I'll turn it over to Alex, and thank you for tuning in.
Thank you very much for the introduction, Jason. Hi, everyone. I'm Alex. I am a software engineer on Lyft's security team. In previous roles, I've also worked as a red teamer, and I maintain a Lyft open source project called Cartography, and my talk is titled Using Graphs to Improve and Scale the Security Decision Making. So in this talk, I'm going to tell you the story of how we built the tool called Cartography at Lyft to help solve some security problems that we've had. And I hope that you'll find this tool and set of ideas useful in your own teams and organizations. So with that, I'm going to get into just telling the story about some problems that we faced at the company. So the first one being that things were moving really fast. And when things move fast with lots of priorities and needing to make deadlines and meet business objectives, there's lots of security and technical debt that happens. You got to ship, and so a lot of issues get shoveled under the rug. Through that process, one consequence that happens is tribal knowledge. So you'll have the more senior members on your team hoarding the majority of the knowledge and how to do something. And a lot of that knowledge won't get passed on to newcomers on the team. And so you have the senior members taking a lot of their time and cycles explaining things to newcomers. And, you would rather have them focused on championing new features and things like that. And when you have too many new things at once, there's always this risk that hypergrowth brings a larger attack surface. So what I mean by that is when your company is continually standing up a whole bunch of brand new features, there's a big risk that an older feature will still be available, but it will still present itself as an attack surface to an enterprising attacker. And so a lot of time, from a red teaming perspective, this is usually a great attack vector to look at your way into a company. And all of these problems are exacerbated by the fact that modern infra is complicated. In particular, permissions models are they're something else. And it was already pretty complicated back in an on-prem perspective when you're looking at Active Directory domain controllers. But at the least with Active Directory, you look at things and then all of your permissions are aggregated into one center of gravity, the domain controller. So everything uses the same set of authentication authorization model. But when you move to things like the cloud and having your applications deployed in multiple places with multiple sets of credentials, with many different vendors and solutions that you have to deal with, this becomes a really big handful, especially if you are a relatively small security department like us. There are lots of knobs and dials to turn and configure your security. There's lots of ways, and a lot of them, they're not necessarily very obvious to set up, and it takes a lot of time. So you end up needing to do a whole lot of research. And the worst part about this is that it's easy to get security wrong, and the consequences for getting it wrong are very high. And of course, everybody can identify with this problem, having limited resources. We only have a limited amount of time in a day and a certain amount of money to get our business objectives accomplished. And especially for us being a small team, we need to automate wherever it's practical. With the multitude of projects that we have, we need to aggressively prioritize and trim down and cut wherever we can, say no to a lot of things. And then so with this consideration of our constraints of business, we came to the idea that we were sort of wanting a self-maintaining map to track all of these concerns that I mentioned just before. We want to be able to highlight structural risks and answer hard to answer questions. And then so what would we do with such a map? What do we want this map to do? So some use cases that we had in mind were we wanted to maintain a central view over all of our technical assets. We wanted this view to be useful for incident responders, and we wanted it to be useful in terms of security research and red teaming and blue teaming. And obviously, if you have a graph, if you have a map of everything in your own infrastructure, it makes sense that something like this would also be very valuable for compliance reports and auditing. And of course, these are the things that nobody really enjoys doing necessarily. And so if you can get that done very quickly, there's a lot of value that you can provide in your own company. While researching things that could accomplish this for us, we looked at existing solutions, and we looked at the ecosystem around us, and we saw that a lot of these solutions were very expensive. Either that or they were proprietary, locked down. And this isn't necessarily a problem, but one of the limitations that we saw was that a lot of these existing products, they were either very focused for specific scenarios, or they were not generic enough to fit the ones that we had in mind. And so basically that they are limited in extensibility. So if we wanted to add an additional plugin, or if we wanted to keep track of additional parts of our infrastructure, it was not exactly a straightforward process through some of these products to do that for us. And so that kind of brings us to the motivation of why we built Cartography. Cartography is a Python tool that it pulls data from multiple sources and represents it in a graph database. And what we found here is that by representing all of our security infrastructure and a lot of things in a graph database, we can answer some very difficult to answer questions. And it helps us see things in a new way that we found very useful. We open sourced this to the open source community about last year in February or March or so. And you can check out our GitHub page over there. And I want to give a quick shout out to my colleague Sasha, who originally had the idea for cartography and representing things out in graphs. And so with that, I want to dive into a couple of scenarios that kind of help illustrate why looking at things in graphs is useful. So we modeled, at Lyft, we use an identity provider, a single sign-on provider called Okta. And with Okta, how this works is that we have a human can be an Okta user. They have that identity, and then pretty straightforward, they can belong to an Okta group, which groups and users belong to Okta organizations. Straightforward so far. And what's really interesting is that Okta as a single sign-on provider, it can delegate access to other providers such as Amazon Web Services. So we're a big AWS shop at Lyft, and then we delegate our accesses using Okta groups. So the way that this works is if you are a member of an Okta group, you can assume an AWS role, an AWS identity. And this AWS identity can be tied to an AWS account. And an AWS account is a way of logically separating out different units of your business. So the way that a company might have it set up is that you can have maybe one department with one account, or one project and one account, that sort of thing. So we have a human effectively able to become an AWS role by virtue of the Okta groups that they are a member of. Okay, and then it becomes, we can augment this data even further by saying that a human can be a member of a different team. We'll add an HR data from, for example, Workday. And so we can get this picture of human is a member of a team, can get to AWS assets. Similar idea here. Human has multiple identities, is part of a team, can be a G Suite user, get to things like Google Docs. And we can also get a view on what Chrome extensions they have installed on their laptop, because Chrome extensions, this is a whole other side topic, but they can present a whole different kind of risk vector to your organization also, depending on which ones are installed on your employee laptops. So, you're kind of starting to see this process about how we started to think about things in graphs. And each new provider gives us an additional picture. And this is a picture of like the different providers that we have in both open source and in, and things that we've played with at Lyft. And so with that, I want to dive in a little bit to a demo on illustrating just exactly what I showed right now. So here I have a view of my graph, and then we see that this is a human user 123. So user 123, that's their email, and they have an Okta user identity. I can see different attributes about when this Okta user, like all the different fields. It might be a little small, but that's not really important for the purpose of my demo. An Okta user, as I mentioned earlier, the Okta user can be a member of Okta groups. In this case, this is the AWS admins group. AWS admins group from Okta is allowed to assume it maps to this AWS role, this set of identities right here. And that belongs to an AWS account for service ABC. So far, so good. So far, pretty straightforward. This is the way that things are designed. Now, one thing that is pretty powerful to look at in terms of the graph is the fact that we can look at, in AWS, there's this feature that allows roles to assume other roles. So what that means is that there's this feature in AWS that lets you, if you are this one identity, you can become another identity. And that's a feature because it's useful for many different legitimate scenarios, like just for flexibility of your deployment of your application in the cloud. And then so this can be fine, but there's some cases where you can assume a role that is belonging to a different account. Is this necessarily bad? Not really. I mean, it could be bad, could be okay, but the point is, you as a service owner, you want to have visibility on this problem, and looking through all these hops and looking through all these different tables, going through the AWS console, looking through your Okta group admin console or whatever it is, looking at it through multiple different views, it's very cumbersome to look at that, when instead you can look at it in cartography with like one view, and you can see all these different hops. So we have the ability to see that this user, by virtue of Okta permissions and through the AWS roles that they are allowed to assume and the relationships in my environment, we can hop between accounts. And if these are two accounts that should not have that relationship, well, we should address that. And this kind of approach helps us answer that kind of question and gives visibility to this kind of problem. So the next thing that I want to kind of show is, how did we do this? And this is there might be a lot on the slide, but then don't get too scared at this. But I wanted to share just a little bit about how our architecture actually works. It's actually fairly straightforward that if you wanted to deploy this in your own infrastructure, it really isn't that bad. So you take our software and then you install a Neo4j database. You can put it on the same compute instance if you want to. It's not a big deal, just if you're trying to experiment. But the idea being that everything goes through this core sync object. So every day or every cadence that you select, it will run this set of plugins that we call Intel modules. So if you want AWS data or Okta data, GitHub data, Google Cloud data, it will run through one of these modules, and then it'll pull those assets, write it to the graph, and you'll get that new data. After that, after we have this new state in the graph, we want to go back and clean up nodes that no longer exist anymore, so you have a clean picture. So that's why we have cleanup jobs. So if there was a previous run, then we'll go back ahead and then check the timestamp, and then if we have stale data, we will get rid of that. This next cool part is after we do cleanup jobs, we run what we call analysis or enrichment jobs on the data that we have. So I'll give you an example immediately, like right after this slide, where we perform different data augmentation. So if we have all of our graph, we can do some logical rules to further categorize things. So the way that I'll explain that is through an example with, is my compute instance open to the internet? And so in this scenario, we wanted to answer the question, is my Amazon cloud instance, is this exposed to the internet or not? And as you guys know, this can be potentially a risk because you have an instance that's open to the internet. You're basically asking to be hacked if you're not prepared for it. There's all these different bots out there scanning for different vulnerabilities and looking for weak passwords and things like that. And you want to make sure that that you have a set of instances that you expect to be open. If they need to be open to the internet. And so the way that we answer that is we have all those different assets in AWS already. We got instances, their network interfaces, the security groups that they belong to, as well as the IP ranges. So the way that we can answer this question is to kind of tie this picture together. So we'll get this path represented in the graph here, and then we'll ask ourselves this question. From the internet, from this IP range, the 0.0/0 range, are there any rules, are there any firewall rules that allow traffic from the internet that are tied to an EC2 security group that happen to be, that we can roll back to an Amazon EC2 instance? And you see, this is basically one of the main reasons why we picked Neo4j over other graph database solutions. It's that you get this syntax that we really like, that you're basically drawing this path, and we find it very expressive. So if this matches, then what we want to do is set this flag, exposed internet equals true. And so this way we can go back and query for exposed internet equals true rather than running this whole big query all over again. We just search for, do we have any labels that match this flag? Similar logic applies if you want to do this with a elastic load balancer in AWS. And then, so I alluded to this a little bit in the previous slide, but if you're running an internet business, you have your EC2 instances exposed to the internet, you want to keep tabs on which ones you expect to be open to the internet, and if there is a new instance that becomes exposed that you did not want to be exposed, you want to know about it. And so this is where we have a drift detection feature. The idea is to detect state changes in time. So with cartography, what we're able to do is you can establish a baseline, so a known good of compute instances that you expect to be open to the internet. And then after every job, if we detect that there is an outlier, if we detect that there is an instance that is internet open that isn't supposed to be internet open, then we will go ahead and fire an alert. And in this case, what we do here is we actually fire a Slack bot alert. So in this case, this actually isn't an EC2 instance. So right here, we got, this is for S3 buckets, but you get the idea. This is the same idea. So we want to alert whenever the actual infrastructure is different from our own expectations. This kind of information is very valuable for when it comes to things like incident response. So right here, if we happen to have a compute instance that has malware on it, or we know that it has been compromised, what do we do? Well, there's lots of, what's our playbook? There's lots of things that we want to loop in, and then we can use the graph to help us with this process, because we've associated things like what service does that instance roll up to? Who is on call for that service? How do we contact them in Slack? And what team do they belong to? What code is actually running on that instance, because we have that all tied up. We have all those correlations together. And then finally, what Jira project is, does that tie up to? This example, I think, is very applicable to a lot of the audience here, especially from an AppSec perspective, when it comes to vulnerability management. We want to know, this project that we did at Lyft was being able to tie CVE risks to software packages and see where they were deployed in our cloud fleet. And then so once we had all of those identified and cataloged, we were able to surface that data in dashboards and track how we were remediating that over time. So we were able to track, what was our progress for improving, our exposure to vulnerabilities in the fleet, as well as what were those actual vulnerabilities in a dashboard. And so being able to consume the graph, consume graph data, for decision makers, who aren't going to be running complicated Cypher queries, that's something that we were focused on as well. With that, I want to talk a little bit about all of I've shown you about, the things that we've been able to accomplish so far, but then there's a lot more potential for where I see the project going. So first off, we have some new data sources and new ways of looking at it coming up and in the pipeline. So what's happened, shout out to my colleague, Andrew Johnson, who made this new feature where, as far as we know, it's one of the first, if not one of the newer ideas, where we evaluate AWS identity access management policies offline. And what we can do is that we can take a human identity, say that so if they are able to assume a given AWS role, we actually evaluate all of their policies to see what actions they can perform on which assets. So in this example, we have Andrew is able to assume this role, and as that role, he is able to read and write from all of these S3 buckets. So being able to map identities to actions on assets. And this is a very powerful, exciting idea, and we're going to add even more. There's a lot of potential for this feature. The other one I want to call out, a shout out to Siler from Oracle. We have a PR in progress that we're reviewing right now for Oracle Cloud. So I've talked a lot about AWS in this talk simply because we're a big AWS shop at Lyft, but it is definitely not the only thing that we are working on. We have GCP data in cartography as well. We're working on adding Oracle also. We want to improve drift detection. We want to improve having automated alerts and actions. And there's a number of different ideas there that I'll share later on if you're interested. And finally, in terms of other improvements, we want to make it easier to view data so that you don't got to write Cypher queries to view everything. We want to improve our performance of our data sync by using DAGs, perhaps by working on using Apache Airflow, or by doing things like rolling our own DAG solution. I don't know, there's a couple of different ideas there. So I want to bring my presentation to a close by thanking our contributors and users. And, if you have found, our goal here with building cartography is to democratize these capabilities so that everyone can have world-class visibility on their infrastructure. So, my hope is that you found this talk useful, you found our tool useful. So please go ahead, check it out on our GitHub. Join the fun. We have an open public Slack channel, Cartography, on the Lyft open source Slack. We do public monthly meetings. Come and say hi. And we want your feedback. We want your code. let us know how we're doing. Definitely go ahead and say hi. And again, thank you very much to Jason. Thank you very much to OWASP for having me.
Awesome. Thank you so much, Alex. Yeah, that was great. I'm personally a fan of this tool. In my day job, I'm actually a penetration tester, and my specialty on the team is actually cloud infrastructure. So the amount of time that I spend, pulling data out of clouds and doing manual analysis, and there's several tools that kind of highlight CIS benchmarks or possible privilege escalation, misconfigured IAM policies and things like that. But to turn that into something that's actionable or really being able to assess things properly against the actual infrastructure versus kind of warnings and alerts on individual items within that infrastructure it's a very time consuming and challenging job. So I'm a big fan of the tool. I've used the tool. It's actually helping me, day to day in my professional work. And just to kind of echo Alex's, request is that definitely if you're interested, join the Slack channel. I've seen them. They're very active to feedback and from the community. He mentioned, that they have the ongoing meetings, but they do things like on upcoming features, putting out a document and letting everybody kind of submit, calls for requests and talking through things. And so, yeah, I think it's exciting. I love to see kind of where, new applications of existing technology can be applied, and graph databases to, managing InfoSec is definitely, a huge step in the right direction. So yeah, check it out, join their Slack. Again, check out the project on GitHub. There's always, more, many ways to contribute to a project. They have lots of good documentation and, but they're moving forward as Alex said. So if you want to get involved, by all means, I highly recommend the project. I highly recommend the team, and being the OWASP Hawaii chapter, it always carries a special place with us when we see, our Kama'aina, our local kind of talent grow on and do big things. And so, so huge props to Alex for, kind of what he's done since leaving Hawaii and getting involved in something that that is truly, a new concept and pushing, the bar further on how we manage InfoSec within our organizations. So yeah, there wasn't a whole lot of questions, so not really much to ask. But given that, I will go ahead and transition to our next talk. Next up, we have Neil Matatal. He works for GitHub, and so his talk is going to be on content security policy, going from idea to afterthought. And Neil, I'll let you take it from here.
Thank you, Jason. That was a great talk by Alex. I really enjoyed it. Thanks for putting that together, and thank you, OWASP, for having us. So we're here to talk about content security policy. If anyone knows me, this is my first talk on content security policy, so be gentle. The idea of going from a concept to the afterthought, we're going to explain this whole journey. And as Jason mentioned, I'm a product security engineer at GitHub. What does product security mean? I don't know. It seems to drastically differ from company to company. But at GitHub, what it means typically is that we either consult on or directly develop things related to the security posture of the application. This can be related to account security or providing a cryptography service or other services to use. It really just sort of depends. I'm also the co-founder of LocoMocoSec, which is a conference based in Hawaii that would have taken place 2 weeks ago and would have had Alex speaking at it, but has been postponed. I have spent a lot of time doing security, but I've also spent a lot of time doing development, and I've gone back and forth multiple times. I have a lovely wife that I met at one of my previous jobs, UC Irvine, and two wonderful dogs named Dory and Crush. And if you get the naming scheme together, that would be fine and emo. So what is content security policy? It is an HTTP response header or meta tag that manages some browser capabilities, but primarily I want to focus on how it controls JavaScript. Once in place, you have certain assurances that potentially bad things cannot happen or the impact of them is significantly lessened, but it can also limit the capabilities of what your application can do. That may or may not be a bad thing. I'm going to hit you with a wall of CSP, not to intimidate you, but just to illustrate that this is a complicated thing. It takes a lot of consideration, testing, experimentation, and planning. It is 1,000 times more difficult to apply it retroactively than if you had built the application with CSP from day one, but practically everyone's in the retroactive mode. Now, just because we're talking about a response header that is a string, that does not mean that you should put it in your web server config with other static strings that don't change. CSP is meant to be dynamic. It is not meant to be static. The primary goal, specifically when talking about JavaScript execution, is you want to work towards a policy that does not include the ability to use inline JavaScript, use the eval function, or load JavaScript from a place that we do not want it to be loaded from. The authors of content security policy thought that including the word unsafe in front of the content that allows you to opt out of this protection. So they use the words unsafe inline and unsafe eval just to remind you, like, it's really dangerous to use either of these functions. It's not necessarily mean you have an XSS bug, but if you were able to remove these allowances, you have a lot of insurances that you don't have XSS. CSP often requires you to rework your application significantly. I do not want to downplay the difficulty of this. Third-party integrations are also notoriously CSP unfriendly. Certain marketing products specifically just do not jive with our policy at all. So, one cannot simply remove all the inline JavaScript, remove all uses of eval, and serve assets from a CD and you can control, but that can be your goal. Simply defining a policy itself is hard. Being able to coordinate a policy across many people, across many applications is hard. Google recently found that most of the CSP out there on the internet provides little to no benefit. I'll talk about this later on. This is a daunting task if you don't do it from day one. But a proper CSP can provide many guarantees. Proper management of CSP makes the technology much less daunting in general. At GitHub, we don't really worry about XSS too much because we have a lot of confidence in our policy. And even if an XSS bug were to be found, we're pretty sure that the impact of that bug would be severely limited in combination with all of our other mitigations. So while it's really a matter of can we wait till the bounty finds it? Probably. So starting from scratch, you're going to want to generate a baseline policy. Crawl your site, come up with a policy. It can be very enticing to think you can hook up a crawler to automate this step and scale out to all your different websites. More power to you for going for it, but you're going to get your policy wrong the first 1,000 times, so I wouldn't focus so much on your first attempt. There's going to be that one page that doesn't get visited very often and isn't linked from anywhere on your website. Or maybe a new feature is rolling out to some of the users, but your test user just didn't have that feature. Maybe someone's using the website in a way you didn't intend at all. You didn't know the functionality was there. There's all sorts of reasons why you should just generate a policy quickly and move on. We'll get to that later. To start showing some HTML, I apologize. I hope this is super readable. But at the very top there, we have a very, very lenient script source value that says self, which refers to the same origin as the page that is loading the document, HTTPS, any URL that uses the HTTPS protocol, the words unsafe inline, which allows for inline JavaScript, that is a script tag followed by some bit of JavaScript followed by a closing script tag, which is different than sort of an externally loaded JavaScript file. The unsafe eval allows the use of the eval function. So we have a lot of green checkboxes, but only one red stop sign. And that is because, for some reason, there was a script tag on the page that tried to load a JavaScript file from an HTTP resource. Unfortunately, apparently this hacker could not figure out how to set up an SSL certificate. Their attack was thwarted. But as you can see, we allow practically everything else. And I want to focus specifically on that third checkbox, script alert 1. The browser has no way of knowing whether you intended that to be there or if an attacker put it there. It just has to blindly execute it. It cannot make that decision on its own. And maybe some of your part of your website still uses inline JavaScript, so you have to allow it. Now, in our external suite animations file, we have the use of the eval function, and then we also have a place where we're dynamically inserting a new script tag. All of this is allowed with this policy, does not provide much benefit. If we take it one step further and we disallow the use of eval, we've really closed a major hole in things that could be potentially dangerous. Again, using eval is not dangerous itself. It's just very easy to use it dangerously. I also want to point out, this is a bit of a historical note, that jQuery original implementations, I don't know if this is still the case, it probably isn't. But when you would try to insert a script tag using the jQuery API, it would actually call eval on that. It would strip away the script tags and call eval. So a lot of people are really confused. They're like, wait, I'm inserting a script tag, but I'm generating an eval violation. It's not intuitive. The next major milestone, we got rid of unsafe inline. So now the inline JavaScript tag with the alert will not fire. The appending of the DOM element will no longer work. We are still able to load the JavaScript files from our same origin and our CDN, again, because it's over HTTPS. This is a significant milestone. Yes, there is still possibility for XSS, but you have more or less put a serious dent in traditional server-side, injection attacks resulting in malicious JavaScript. Let's keep taking it further. Here we've moved our Suite Animations library into a more formal animations library, and we are hosting it on our own CDN. This is important. We control what's on our CDN. We don't control what's on Foo CDN. For example, Foo CDN might be serving an ancient vulnerable version of the library, but since we allow any HTTPS URL, not specific to that CDN, I guess, you just have no guarantee about what JavaScript is being loaded. Maybe I'll just load an old version of jQuery and just completely overwrite everything and abuse it that way, for example. You wanted the most recent version. I loaded a super ancient version. And finally, we changed our CSP to be in one of the most strict possible formats. We are only loading it from our CDN. We generate that bundle on deploy. We know exactly what's in it. We have cryptographic assurances that it's not being changed during the deploy time. This is a great state to be in. This is the state that github.com is in, and it is what allows us to have a lot of confidence in the protections that we've applied. And just to take it a step further, we also use sub-resource integrity. That little integrity attribute assures that if somehow our CDN were hacked and someone changed the content of that bundle, they'd also have to hack our application to change the integrity attribute. So not only do we have control over where it's being loaded, we have control over what's being loaded. But again, it's not all great. It's really hard. The CSP authors tried to use a few tools to specifically combat the problem of removing inline JavaScript. There are reasons to use inline JavaScript. I feel like those reasons are being less and less used because they're harder to justify. I think a lot of it was based on misconceptions about performance, or having to support some antiquated browser that just cannot handle modern code. So sometimes you just have to deal with it. So the authors provided two methods. One includes adding a nonce attribute to the script tag, and as long as that value is matched in the script source directive at the top there, it will allow that inline JavaScript to execute. That's good. That's really helpful. Problem is, if you have dynamic JavaScript, if you have some server-side code inside of that little snippet, you're still potentially opening yourself up to XSS. This is an improvement, but I don't think it should be a final state. The second script tag miraculously executes, and the only difference between it and the following tag, which does not execute, is the numbers 2 and 3. 2 is indeed different than the number 3, which would mean that if we were to hash the results, we would get a different hash. So there is only one hash up there, and you'll just have to take my word that that is what hash that allows that script tag alert2 to execute. And then the script tag alert3 does not have a corresponding entry. It will not execute. So again, if the attacker is able to insert a script tag, unless they know the nonce, which they can't, shouldn't, hopefully, and unless they can inject a value into your content security policy, again, hopefully they can't, they really can't do much. Script gadgets are the thing I was alluding to that makes most content security policy bypassable in a way. These are dangerous APIs built into a lot of the common frameworks or libraries that people use. Again, if your source list is a little too lenient, I could just load a bad version of the library that contains vulnerabilities and exploit these as well. This sort of like API for XSS kind of exists in most of these frameworks. I am not a JavaScript framework expert. I encourage you to look at the Black Hat talk from the gentleman at Google, who do a really good job of breaking down the various libraries, their problems, and how it interacts with a technique called strict dynamic, which I will talk about later. So CSP has a reporting mechanism that will post JSON containing information about any violations wherever you specify in the header itself. Reporting can be useful for two purposes: figuring out and maintaining the correct policy, or to potentially detect an attack or flaw. I think I found more bugs with CSP than attacks. I used to be a big proponent of filtering, massaging, and augmenting reports that end up in some, quote, big data, unquote, source for tracking attacks. I didn't really see that pan out. I now take a modified stance where collecting reports is a good idea, but practically only for maintaining that policy. Again, when you have CSP in place and you're confident it does a good job, how important is it to know about a potential XSS bug right away? And unless it's wormable, it's going to get lost in the noise. CSP is very noisy. It's very hard to see any needle in a haystack. So unless you're talking about a TweetDeck wormable XSS, CSP is not going to detect an attack in real life. We find that reporting is only useful when the report itself comes from a relatively up-to-date browser that hopefully isn't riddled with questionable browser extensions. Again, extensions are a huge source of CSP violations. I'm looking at you, LastPass. If you use the product you develop, your employees would be a great group to target for actually rolling out the policy itself. We only care about reports that come from our employees' browsers because we have confidence we can trust those reports. We don't take reports from the general public anymore. It just became too much work for too little benefit. And frankly, it's been conservatively 3 years since I've even looked at a CSP report. So at some point, they just really don't become that valuable. I'm not quite sure how you approach this problem if you build a product that you don't use daily. I have not put enough thought into that, however. When you're done with CSP, you're mostly done forever for some value of done. You can't develop a new feature that isn't compatible with your policy because the policy doesn't allow it. You can't modify the policy without purposely circumventing systems in place for example, the security team to detect changes. So, if you're looking to add a third-party integration, you got to confirm that it either works exactly with our policy as is, or confirm that the third-party service is willing to work with us to come up with some custom solution to make it work. Sometimes it works, sometimes it doesn't. But all we know for sure is we have great control over what is being added to our application. CSP has a report-only mode. I mentioned that you can sort of take things for a test drive, while you can use your employees to test out actual changes. You know, come up with a policy you're relatively confident in, apply it to some employees, apply it to more employees, apply it to all employees, but give them an escape hatch. You don't want to break their workflow for security. But once you have relative confidence that none of your employees are getting blocked in what they're doing, you can have a lot of confidence that the general public won't run into issues. I'm only going to briefly mention trusted types. If general CSP can be effective at putting a dent in server-side XSS, trusted types would be the DOM XSS equivalent. The sentence on the page, an API that allows applications to lock down injection sinks to only accept non-spoofable typed values in places of strings. I often joke that my job is just generating and parsing strings, and I think trusted types kind of proves that. As you're passing data, for example, from a user input into a JavaScript function that is classified as a sink, something that can lead to XSS, passing down the string of garbled data is the same thing as a browser rendering whatever HTML you give it. It can't tell what's good or bad. So trusted types allows you to sort of define what happens whenever you cross over one of these boundaries. And based on what is being passed in, you can sort of have some assurance that, for example, something's been sanitized, or something is definitely a number and not a script tag. I'm probably doing a little bit of a disservice here. I hope I didn't misspeak, but I definitely encourage you to check out trusted types when you can. The Google team had recently rolled this out, so it works. Congratulations, Lucas, Koto, Artur, whoever else is behind that. That's a big deal. I do hope to get to it someday. And my offer from last year's LocoMocoSec, where if you find DOM XSS, I will implement trusted types, still stands. I briefly brought up strict dynamic. I want to go into it a little more. Everything we've sort of talked about now, I would call pre-strict dynamic. Strict dynamic is definitely a game changer. I would say it offers a lot of flexibility, increases security a lot, but I would say still falls short from the traditional CSP that I'm more comfortable with. That's easy to say from someone who's working on an application that implemented CSP 6 years ago and is more or less in maintenance mode. I would definitely have a different attitude if I was retroactively applying it to a new app that is sloppy. So let's go back to our original not so great policy: unsafe inline, unsafe eval, HTTPS. This is the I give up whatever script source equivalent. I guess star would also be there. So let's just say this is the best policy you can generate. There's just too much inline script. All your libraries use eval left and right, and you got to dynamically load 15 libraries. It's 15 JavaScript libraries on a page load from 3 different CDNs. It's just again a mess. Well, simply adding strict dynamic and adding a nonce to your script tags, you can essentially change the scenario quite a bit. New browsers will know to new browsers that understand strict dynamic will actually ignore everything else, specifically the unsafe inline, the unsafe eval, the HTTPS, self, anything. So as far as a new browser is concerned, it only sees the bolded values. Now, if your browser does not support strict dynamic, it will fall back to the original behavior. So CSP has done a confusingly good job of being backwards compatible without breaking things. So this policy should work on every browser, and for the browsers that understand it, they will get this extra layer of protection. I know Chrome supports it. I'm not sure where the other browsers are today. I think this is going to help dramatically, so I hope it catches on. Let's see. The main thing here is that you have code that uses inline JavaScript, and you have code that uses eval, so you can't just turn it off. Everything would break. But what strict dynamic allows you to do is any JavaScript that has a nonce, will execute. So for example, inline JavaScript with a nonce tag will continue to execute just before. But if you're loading an external JavaScript file that has a nonce tag, the contents of those files are sort of automatically trusted. So, let's go back to our code sample where, we have the various loaded sources. And we'll see how, without any code changes, we are able to sort of allow the same behavior with enhanced protections by just adding a nonce attribute in a few places. So our script source, strict dynamic with our nonce. That top one still won't load because it's over HTTP. Poor hacker man still doesn't have a certificate. We're allowed to load that relative assets suite animations because it has a nonce attribute. We're allowed to load the foo CDN because it has a nonce attribute. Even though it would have been allowed because it's HTTPS, it would have been, the fact that it's HTTPS doesn't matter. The fact that it has a nonce is what matters. We still have that inline alert. We have declared that, yes, this alert box is supposed to be there by supplying the nonce. Our script tag without the nonce, again, will not execute. Our eval contained in that external file will execute because it was provided in a nonce source, and our inline JavaScript insertion will execute. If we were to load another third-party resource, it would be loaded regardless of the circumstance. The sort of chain of trust will go down. So I was told there would be code. The abstract mentions the code that GitHub uses. It's actually quite simple, and I think I can get it in the next 4 minutes. You need to have a way to define a global policy. There is a base policy. You need to add a way to dynamically modify the policy during runtime. You need to have a familiar and documented API. Yes, we're working with a string. Yes, we're working with a header, but content security policy is a complex object, and we should operate it on it like such. A familiar and documented API means that at a certain point, there's enough tribal knowledge and enough documentation and enough code patterns to sort of pattern match from that everyone at GitHub understands how to modify CSP, and most of the time, we're not even involved, we, the security teams. Just to briefly go through the model view controller, I'm sorry, real programmers, I'm going to butcher this. As far as Rails is concerned, a model is some collection of data, typically a database row and its foreign keys. A view is sort of where you intermix HTML and data such that it, spits out some HTML for a browser to render. The controller, takes the inputting request data, generates the models, and then spits it out to the views. Again, this is a very terrible example. But the point here is that it doesn't make much sense to manage CSP at the model layer. I'm sure there is a use case. I've just never seen it. It does make a lot of sense to do in the controller and views because the views are might be right next to the content that requires a content security policy change. And a controller is a logical way to think of a set of endpoints that just all have the same functionality. So this is Ruby on Rails code. The application controller is where all controllers inherit from. There is an append content security policy directives call there, and it looks for a method called a constant called CSP exceptions. In our example controller, we define that constant to say, hey, I want foo.com added to the list of frame sources. The before action itself is what calls that method, which then reads that constant, which then makes the CSP change. That before action is just Railsisms for call this method before, and then you can specify, in this example, only show. So the show action will get the frame source addition, but the index action will not. And the example below is a lot more wide open and a lot less structured because CSP is, dynamic. We just have a generic, if feature enabled method, and we append some third-party source. That feature enabled method should be, literally anything you want. Is the user logged in? Do they have a feature applied to them? Does the day end in Y? The flexibility needs to be there. And you can have dozens of these modifications on any given request, and you're always sort of exactly sure why that modification happened. Another common example is you have a bit of reused code. That file name that starts with an underscore is a Railsism to say, like, this bit of snippet can be included in many places. So in this case, we have a button to some third-party payment processor, apparently, and we make the modifications directly in the code itself. Now, lastly, I talked about how you can add a nonce to tags. Yes, you can generate a random string, you can plop it in a header, and you can add it to a JavaScript tag, or you could just have the framework do it yourself. you have this nice method nonce JavaScript tag that will either reuse or generate a nonce that is then added to the header automatically and is then automatically whitelisted, is automatically allowed to execute regardless of what else is on the page. But sometimes you just can't make enough modifications. Like sometimes the page is just so different that it doesn't make sense to try to whittle away your existing policy. You know, for example, your 404 page probably is way different than your normal page, but it's still a good idea to have CSP on there. And doing so with a static file policy that is then generated and is easy to find with grep is pretty darn useful. That's it. 2 pages of code, or 3 pages of code, sorry, was all it took for CSP to be implemented at GitHub. There are over 150 specific modifications to policies. Like I said, I haven't made a change to the policy myself in years. We are generally consulted, but we have sort of warning systems in place if something, if the policy goes away, we don't like it. It's a beautiful system. I don't think we have time for questions, but definitely go ahead and ask them. And I do want to end off by saying the systemic racism and brutal treatment of Black people must stop. There is no place for hate and racism in our society. LocoMocoSec is matching donations to various charities, and we encourage you to donate as well.
Awesome. Thank you so much, Neil, and thank you for your thoughts at the end of the talk as well. I really appreciate that. We're about out of time, so I'll make this real quick. But I do want to thank both Alex and Neil for presenting their talks today, representing Hawaii. We kind of have a Kama'aina gone to the mainland and somebody on the mainland that's come to Hawaii and kind of embraced Hawaiian values, and that's very apparent in some of the things that Neil's doing with LocoMocoSec. And I just want, I really just want to encourage everybody. We are from Hawaii. We live with the Aloha spirit. The Aloha spirit is caring for one another, lifting each other up, regardless of race. Looking after your neighbors and the people around you. So if anybody could take anything away from the Hawaii chapter specifically, please treat each other with aloha. Break down the barriers of race and systemic oppression here in the United States and around the world. Beyond that, if you are in Hawaii, I encourage you to join the local OWASP chapter. We're on meetup.com. You can find us on Twitter at OWASP Hawaii as well. And I want to thank OWASP as a whole for allowing this, creating this event and getting everybody together to do something virtually all around the world. So aloha to all the other chapters. Coming up after this is our Chile chapter, and that's it. So aloha, everybody. Take care.